Maruf, am I audible?
Yes.
Yes, sir. Audible, sir. Audible.
Good evening, all the participants. So today we have with us Professor Ramesh Bansal. Sir has more than 25 years of diversified experience, which includes industrial experience, teaching experience, as well as accreditation, research, and academic leadership in several countries. Currently, Sir is professor in the Department of Electrical Engineering at University of Sharjah and extraordinary professor at the University of Pretoria. Previously, he was professor and group head in the ECE department at University of Pretoria, South Africa. Prior to this, Sir was employed by the University of Queensland, Australia, University of South Pacific, Fiji, and BITS Pilani, India. Professor Bansal has significant experience of collaborating with industry and government organizations. He has made significant contributions to the development and delivery of bachelor and masters in engineering programs for utilities. He has extensive experience in the design and delivery of CPD programs for professional engineers. He has carried out research and consultancy and attracted significant funding from industry and government organizations. Professor Bansal has published over 450 journal articles, conference papers, books, and book chapters. He has Google citation of over 21,000 and H-index of 69. He has supervised 25 PhD, 5 postdocs, and currently supervising several PhD students. His diversified research interests are in the area of renewable energy and smart grid. Professor Bansal is an editor of several highly regarded journals, including IEEE Systems Journal. He is a fellow and chartered engineer IIT UK, fellow Institution of Engineers India, and senior member of IEEE USA. So without delay, I request Sir to start this session. Sir, over to you.
Thank you, Professor Rajesh, for kind introduction and inviting to deliver a lecture on this very important event. So, dear participants, I will be presenting on the topic building resilient power grid through adoption of renewable energy technology. First of all, I would like to congratulate Professor Rajesh for organizing such an excellent program. And I am happy to know that there are more than 200 participants. So this is really a big number, big event. So here maybe I will discussing about 1 hour, 15 minutes, and then you will have opportunity to ask some questions to make this session more interactive. So in the renewable energy technology, what I am going to briefly discuss, what are the current trends for the power generation through mainly the renewable energy distributed generation. Then I talk about some of the distributed generation integration requirement. What are the main emerging and most commercial successful distributed generation technologies? Wind, both onshore and offshore, photovoltaic systems, microgrid, and briefly talk about the smart grid, electric vehicle. So these are the outlines. Some of these topics might appear to have that covered. Basically, these are the main topics which we discuss around the renewable energy. But you'll see that you'll find a lot of new information as well. So here, why renewable energy technology? In past, worldwide electricity was being generated and still continuing through these fossil fuels like coal, oil, natural gas. And through this fossil fuel, mainly coal-based or oil-based generation, huge amount of emission is also produced. You can see from the slide. So this huge emission like this, Earth no more is able to afford. We have already started seeing its consequences in terms of weather change worldwide, global warming, change in the weather pattern as well. You might have heard in the news last year, the flood in Dubai, or maybe, very hot weather in Europe. So all these issues, what we are, coming through or observing, global warming, and this emission being produced mainly because of this electric sector, which is like one of the big sector consuming this, coal. Then another big sector, what we are talking about, the transport sector, using this petrol, diesel. But now we also started looking for alternatives in terms of electric vehicles. So these emissions being produced is badly affecting the health of the human beings and also to the vegetation. We are, listening so many, issues, health issues, diseases, which we hardly used to hear, but now very, very common. So we cannot continue, going through this electricity generation based on the fossil fuel. So we have to see the alternatives. In fact, to get an idea that how much coal we are burning, and how much emission will be produced. So this I took a very simple, small scale thermal power based, like this small scale model. So boiler capacity is 30 megawatt and the output is 12 megawatt. So efficiency around 40%. So for this, a very small size, power plant, you can make a very good estimate that how much coal is used in power plant. And through this, you can make an estimate, like in our country, how much coal would be used in all the power plants. So you can make an estimate about that. So how much coal is generally used for this size of power plant? Coal used is 1 kg per second. So depending upon the size of the boiler or the installed power capacity, you can easily make an estimate of this coal being used. For example, if you have this boiler capacity 1200 megawatt, so 1200 divided by 30, 40 times of this size means like the 40 kg per second coal will be required. This is for 1 second. Then you can make an estimate for the hour, days, that how many coal will be required every day. So basically, this is very interesting slide. Through this, you can get an idea that how much coal we are burning. And then you can also relate that, how much emission is being produced. You can try to get an idea that, old days when we used to burn this, coal, for this like home heating purpose, just like say it could you 1 or 2 kg coal and used in the home, and then issue how much this smoke it is producing, how much inconvenience it will cause, And here we are talking about the huge amount of coal burning and then emission being produced. So this is like the huge, like I ask all the participants to get an idea that in our country, the power installed capacity, I think around 400 gigawatt, and coal being used maybe say more than 200 gigawatt. So you can make an estimate how much coal we are burning, how much emission is being produced. So please, everyone, try to get an idea so that you can get a feeling that how much coal is being burnt. Long back, when I worked at BITS planning during 99 to 2005, we used to have the collaborative program with the NTPC, National Thermal Power Corporation. And I visited almost all the power plants for this NTPC. So I have a good idea that, how much, coal is being burned, how much emission is being produced. Then you can see that, when we are burning coal, how much, quantity of air would be required for the burning. So it is 10 times. So that based on that, you would have to design the fans which will supply the air. Then, of course, to make an estimate that if this is the 30 megawatt capacity, efficiency is around 40%, where the 60% is going. So it's very crude model. So you can say around 10% power loss is through this gases. Then significant power loss occurs in the condenser. So here you can see their steam being produced, which will rotate the turbine and produce the electricity. Then another point you can see that, when we are talking about the coal-based power plant, you can see that significant quantity of water is required for the cooling purpose in the condenser. So for 1 kg per second of coal, it requires 360 kg per second of cooling water. So obviously this plant, we will be locating close to some river. Even like if we don't have any river nearby, so how we can manage. So I recall long back for one of the NTPC power plant in I think in Andhra state, in Visakhapatnam. So they used to take water from the sea for the cooling purpose. Of course, that water has to be, conditions to make it suitable for being used in the power plant. So if you'll see the fuel share, the fuel share that is used in the power sector for electricity generation. So here you can see that the use of coal is obviously declining because of the obvious reason that causing the huge amount of pollution. Even some countries are coming with the regulation that there will be no more approval for the new coal-based power plant. Whatever the power plants are existing, once they have the useful life, and then shut down, and no more new coal-based power plant. Then you can see the combined large hydro and nuclear. So you can see which is also a little bit declining. So the reason for that is that mostly the large hydro sites have already been harnessed. And then, of course, many countries are not very supportive of the nuclear. Then talking about the gas, you can see that use of the gas is quite stabilized. Gas is not as problematic as we have coal for electricity generation and emission causing from the gas. And gas we also use for some other purpose like cooking. Our main interest worldwide is now through the renewables, mainly through the small scale generation or in the large quantity as well, renewable energy integration. If we see that how much renewable energy has been integrated worldwide, if we see around 2025, so the share may not be like more than 13% or like that. Of course, if we include the large hydro, then this share will be obviously high. Large hydro is also considered as the renewable, but we are talking about the small scale. So in the small scale, this share worldwide, it may not be more than 15%. So now let us see about the current trends for the power generation. And of course, when we are talking about the research being conducted in the power area, so obviously this is one of the very hot topic, renewable distributed generation, microgrid, small scale generation. So this is the current trend. If we are conducting research in the conventional topic, conventional power generation, so it may be very challenging to publish it. So here, like as we can see that in the previously we generate electricity through the large size generators based on the coal, nuclear, or hydropower plants. So obviously these power plants will be located far away from the load. They will be close to the coal mines, for example. So they will have large transmission and distribution losses because of the far distance from the load center. So in recent time, this generating electricity through large generators are no more economical if we consider the transmission and distribution losses. So the current approach for electricity generation is through small scale power generation close to the load center through the renewable energy technology, which have several benefits. Two main benefits are that reduction of the grid losses, transmission and distribution losses, because load is very close to the generation. And as we know that the power loss, I square R, copper loss, is dependent upon the resistance. Resistance is proportional to the length of the transmission line distance. Then you can see that renewable energy being green technology offer the positive impact on the environment. Now this renewable distributed generation, where this renewable energy distribution power plants should be placed, what should be the location, what should be the size of the renewable power plant. So this has to be decided after doing the proper study, simulation study. This paper, you can see one of the paper, location and sizing of the renewable power plants. So you can find in the literature large number of research papers talking about the optimum location and sizing. So this is very important to get the several benefits associated with the renewable power distribution integration. If we just place the any size or any location renewable power plants. So we may not get these benefits what we can get from the renewable integration. Then with the renewables, there are several issues, technical challenges also associated with the renewable power integration. As we know that renewables like wind, photovoltaics, solar, they are highly fluctuating and intermittent in nature. Wind can fluctuate plus minus 20% in few minutes. Same way solar, during night, no sunshine, during the day, morning clouds can come. So they are fluctuating and intermittent in nature. Then another issue what we see is that these traditional networks have not been designed for the distributed generation integration. So we may need to create the infrastructure for the renewable power integration. When we are integrating distributed generation, then obviously power flow becomes bidirectional. So we can draw like this distributed generation generally integrated this distribution system. So power can be drawn and power can be fed also through the distribution system. So power flow becomes bidirectional. And when power flow is bidirectional, then existing protection scheme may not work well. The protection scheme may need to be significantly modified. As previously for the conventional power system, we used to have this, single direction protection relay. So generally the current direction was from generation to the transmission to the distribution. But now with the renewable integration, power flow has become bidirectional. So this single directional relay may not work well, and we may need to significantly modify the protections. So there are several challenges, but the point that I mentioned, one of the biggest issue what we have with the coal-based or fossil fuel-based power plant, because of this emission, we are looking for worldwide the sustainable and clean source of electricity generation. So the current trend is to have electricity generation through small scale renewable integration. And then another issue, you also know that how much reserve we have for the like this coal-based system. How much coal we can use, how many years, maybe 30 years, 50 years, or maximum 100 years. So when finished, what is the next step? So obviously from that perspective, we have to see also the alternative in terms of renewable and sustainable means of electricity generation. So one of my researcher, PhD student, wrote very nice review paper talking about the integration of distributed generation into the distribution system. So there are several, benefits listed by the researcher, technical benefits, economic, environmental, with the renewable distributed generation in terms of reliability improvement, voltage profile improvement, quality improvement, reduction in the power losses, economic benefits, environmental benefits. I'm not going into the detail of that, but you can refer the paper. Then talking about the types and technology of the distributed generation. So this we can classify based on the renewables and non-renewables distributed generation technology. In renewables, we can have several technologies like the solar, photovoltaic, wind, both onshore and offshore, geothermal, small, mini, micro hydro, biomass, fuel cells, etc. Then talking about the non-renewables, gas turbine, micro turbine, and diesel generators. So we have several distributed generation technology. When we have to use the distributed generation technology, then we need to compare their performance in terms of technical and several other aspects. So if we just see that these various distributed generation technologies, renewables, non-renewables, compare few aspects, like generally what size these distributed generations are available, what are their efficiency, what type of fuel is used, how much is the emission. So here, when we are talking about the non-renewables like the reciprocating engine, gas turbine, micro turbine, then renewables, fuel cells, PV, wind, small, mini, micro hydro. What size generally these are available? Diesel generator can be from very small size, can go up to few megawatts, quite big as well. Then gas turbine can be available up to 20 megawatt. So, and then I'm not going into the detail, which is very much self-explanatory. What will be the efficiency of these plants? Yeah, if you talk about the diesel efficiency, say around 40%, gas turbine 30-40%. Then, as we know, PV efficiency generally around 15 to 20%. Wind efficiency is around 40%. Hydro 80-90%. Then type of fuel used, like here in this reciprocating engine, we are using the diesel, or in this gas turbine gas. But other great advantage with the renewables is that you can see that the fuel what we are using is either wind or sunshine, which is free. And of course, the water, you can also consider that to be almost free. So they are just from the nature. This is another great advantage from the renewables, that mostly the fuel used in the renewable power plants, they are free or almost free. And if you compare the emission, so diesel, you can see how much emission of the order of like 600. Then if we compare with the renewables, wind, PV, almost no emission. So this way you can see that there are great advantages for the renewable power integration. However, you will see that, as I mentioned in the previous slide, that there are several challenges as well with the renewable power integration. As I mentioned in the previous slide, like we can see that they are highly fluctuating and intermittent in nature. So if there is like, for example, no wind, it means no electricity will be produced. So this way, you'll see that even sunshine during night, no sunshine. So the renewables, they are highly, fluctuating based on the weather condition. So this way, a lot of instability, uncertainty associated with the renewable power plants. When we are talking about this power system, in power system, we have to make the balance between the electricity generated and consumed. So there has to be a proper balance. Otherwise, there are several power quality issues as well. So in that situation, how we can make our power system reliable and sustainable. So there are several challenges as well associated with the renewable power plants. So now talking about when we are integrating distributed generation, you'll find that there are several
हम ये हम
interconnection requirements we have to follow. There is one IEEE standard, IEEE 1547. So this standard is applicable for the small size DG integration. So what are the several distributed generation interconnection requirements? So some of these requirements are listed here. Fault ride through capability, voltage and frequency operating limits, active power control, reactive power control, other requirements in terms of power quality, protection, etc. So fault ride through capability, what is that? So when fault occurs on the power system, so how these renewable power systems will behave? In past approach was that when fault occurs, so these renewable power plants will be disintegrated from the power plants because their safety and security was more important. But in the current time, so the renewables are not immediately disconnected, but even they try to help in recovering of the fault condition as well. Voltage and frequency operating limits. As we know that like the nominal frequency 50 hertz. So how much deviation we can afford to have? Not much, like frequency 49 to 51 hertz. And same way voltage, how much variation is permissible for voltage? Plus minus 10% in the transmission system, even in the distribution system, plus minus 5%. Then, as I mentioned, we have to keep the power balance in the generation and consumption. So both power balance for the active power and reactive power as well. Little bit imbalance is permissible, but not much. So this active power control. So this active power control, how much power is being generated at the same time, it has to be utilized in the real time. If there is some unbalance in the generation and consumption, so it will be reflected in terms of frequency variation. Frequency will go up and down. So this frequency, as we know in the power system, we have to maintain within the operating limits. So this slide gives you the two examples. One is the case for the upper one is the case for the Denmark, and below one is the case for the China, for a small size wind power integration. So here in case of Denmark, you can see nominal frequency operation is between 49 to 51 hertz. If the frequency deviates from this, then within the specified period of time, we have to bring the system back to the normal. If it takes more time, so the power system can become unstable. Then you can see that for the case of China, even you can see the normal operation bandwidth is narrowed down between 49 to 50, 50, you can say 51 hertz. So every country can design their own grid codes. So generally, many people will think that with the integration of renewables, the quality of power will be affected, but it is not the case. So how we design the grid codes and how strictly we implement, even with the renewable integration, quality of power can be improved as well. So I talked about the fault ride through capability, briefly talked about the voltage and frequency, operating limits, active power control. When we are talking about the active power control, we have to take care for the several, aspects. As we know that now we are operating the conventional power plants along with the renewables. We don't know how much will be the demand for the next day. It will depend upon weather conditions, mood of the people. So basically demand keeps on changing and it is very difficult to predict accurately. The electricity demand has to be met. So renewable power plants operate along with the conventional power plants, and electricity has to be supplied with a certainty. Renewable power plants depend upon the weather forecasting, and the conventional power plants have to kept in the hot conditions so that they can supply the power even if there is no wind, for example, next day. So, but when we have to keep this plant in the hot condition, then we have to continuously keep on burning the coal. So it means it needs, proper planning, proper coordination, and when there is sudden load increase on the power plant, how this demand will be met. What is the ramp rate of the different types of power plants, coal-based, gas-based, or renewable power plants. So this is very important in the modern power plants. We talk about the reactive power control. The reactive power is very much associated with the voltage balance, voltage control in the power system. What we talked about that voltage you have to maintain within plus minus 10% of the nominal voltage. So this voltage will basically depend upon how much proper balance we have between the reactive power generation and reactive power utilization. If there is significant mismatch, so this will be reflected in terms of voltage variation. Now, let us briefly talk about the global installed capacity from both the onshore and offshore wind farm. At the end of 2023, 1 year earlier, so you can see the total installed capacity worldwide from the onshore power plant. It was, you can say, around 950 gigawatt. Significant power from the onshore is being produced only China, around 43%. Then the other countries like, significantly producing the power from the onshore wind. US, Germany, our country also doing very well. Spain, Brazil, etc. Then talking about the offshore install capacity. So this offshore is relatively new technology. So this is comparatively very costly as well. So previously, electricity generation from this offshore was mainly in the Europe. You can see the mostly in the Europe countries. But in the past 4 or 5 years, China also started taking great interest, and you can say around 50% of the offshore capacity is in the China. So several countries, they have, the sea near to their countries, like our country also has sea. So in future, we may also start generating electricity through the offshore. As I mentioned, currently it is more costly as the technology matures. So we may see that the generation of more and more power will also come from the offshore wind turbines. So this is like one of the very promising technology. And the other great advantage with this offshore is that many big cities worldwide, you see that they are located on the coastal areas. Like if I work in Australia, so all these, cities, Melbourne, Sydney, Brisbane, all just like all on the coastal areas. So load is very close to the generation. So in that case, basically, in future, we may say that this the installed capacity from the offshore likely to increase significantly. So you can see that the current installed capacity, both onshore and offshore, you can see close to say 1000 gigawatt. Then how much capacity every year is added. So the growth rate every year is around 10%. If at the end of 2023, say total installed capacity was 1000 gigawatt, then at the end of 2024, how much capacity it would have been added. So this will be around 10% of the whole previous cumulative installed capacity of this 1000, so around 100 gigawatt. So every year growth in the installed capacity from the wind is around 10%. We will also see how fast the growth is there in the solar photovoltaic systems as well. Now, when we are talking about the power from the wind, so now you can see that this, when we are talking about wind power plants, we are not talking just like the small size, but they have power plants which are really very big size power plant. It's like China plans to have, a very big wind power plant of the capacity 20 gigawatt. Then in our country, we also have 1.6 gigawatt wind farm. Then another 1.5 gigawatt in Tamil Nadu state. Then US also, there are several large size power plants. So talking about now, basically, like how much we can expect to have this cumulative installed capacity from the wind, say by end of 2050. So currently we have seen that installed capacity is like around 1.1 gigawatt. How much we can expect by 2050? So you can see the different models proposed. So what we may expect that by 2050, we have installed capacity 4,000 gigawatt to say 6,000 gigawatt. So it means what we have currently around 1,000 gigawatt. So 4 to 6 times of the current installed capacity, what we may expect by 2050. The generally growth rate is of the order of around 10% every year. Now, let us see how the development in the wind turbine technology has taken place, how the size of the wind turbine has increased with the corresponding increase in the rotor diameter, wind turbine size, rotor diameter. How much is the power electronics rating and what is the role of power electronics, what the generator technology is being used in the power plants. So when we talk about the year around 1980s, when the power from the wind almost started. So the size of the wind turbines used to be around 50 kilowatt, and the rotor diameter, wind turbine blade diameters used to be around 15 meters. So there was slow increase in the wind turbine ratings with the corresponding increase in the rotor diameter. So by 1995, we used to have around 1,000 kilowatt, means 1 megawatt size of the wind turbine, single wind turbine. The rotor diameter 50 meter. Then year 2000, size increased to 2 megawatt, and the rotor diameter increased to 80 meter. What was the generator technology? Previously, you saw that we used the squirrel cage induction generators, mainly squirrel cage. Then later part, we also started using the slip ring type of induction generator as well. So here, role of power electronics was almost negligible. You can see that in year 2000, we started using the very popular generator technology, doubly fed induction generator, DFIG. So this DFIG generator technology very popular, still today very popular. With this doubly fed induction generator, as the name indicates, we can generate electricity both from the stator and rotor terminals. So here, this technology is very popular. Then as we keep on growing the size of the wind turbine, 6 megawatt, 8 megawatt, 10 megawatt, corresponding rotor diameter also kept on increasing. You can see in the slide 190 meter size of the wind turbine blades. Then what is the another popular generator technology? So here you can see that the another popular generator technology what we have is the permanent magnet synchronous generator, PMSG. So here the role of power electronics becomes becomes, you can see, is 100%. So you can see that mainly we are using the generator technology. What we have is Day5 or PMSG. So you can see some of the reference I provided. You can see this first paper. It very nicely talks about the power electronics, drives, controls, electric generators for the large wind turbines. It talks about in detail about this generator technology, role of power electronics being used in the wind power plants. So this is, again, you can see very interesting slide, very recent as well, based on this Global Wind Report 2024. So here you can see for the both onshore and offshore. For onshore, what is the largest size of wind turbine, what we expect? The current size for the onshore largest size is 10 megawatt with the blade size 220 meters. What is the largest size available for the offshore? It is 18 megawatt single wind turbine with the blade size, you can see, is wind turbine blade size 280 meter. Then how much we can expect, like say, in next few years? So in offshore, it can go for 25 megawatt, estimated, of course. For onshore, it is 15 megawatt. So you'll see that what the wind turbine blade size we are talking is, for example, 300 meters. So can you imagine how large is 300 meter? If we see one football ground or hockey ground, so around 100 meters. So it will be 3 times of the football ground size. So you can see how big would be the wind turbine blade size. It is very challenging task for the erection and commissioning of such a large size of wind farm. Now the question will come, why we are going for this large size of wind turbines? What is the benefits? What are the, why we are going for the large size of wind turbines? What are the benefits? Although it is very challenging task to construct and install such a large size of wind turbine, you will see that we have very popular equation for the power from the wind, half rho A V cube. So power produced from the wind is proportional to the wind density, area of these wind turbine blades, and of course wind velocity, cube of the wind velocity. Obviously, we would like to have this wind farm in the very good wind velocity so that we can produce more power. So power produced is cube of the wind velocity. Now you will see that the power produced is also proportional to the square of the area, half rho A, area proportional to the area, and area we know that is pi by 4d square or pi r square. So the power produced will be proportional to the square of the diameter. For example, if you have the diameter, say 10 meter, power produced will be square of 10 is 100 units. If we increase the diameter, say from 10 to 20, then power produced will be 20 square, it goes to 400. If we increase the diameter just double, so power produced increases 4 times. Obviously, the cost will also increase as we increase the diameter. Cost increase is generally in the same proportionate. As we double the size of the wind turbine, cost will become double. But power produced will increase 4 times. So it is quite economical to have the larger and larger size of wind turbine, as power produced will be more compared to the cost. So this is the main reason that the size of wind turbine is continuously increasing. And then of course you can also see the role of power electronics was extremely important because of the development in the generator technology. The role of power electronics is very important. We use Day5. Here the role of power electronics was 30%. In terms of for PMSG, the rating of the power electronics is 100%. Then you can see that there is another small size wind turbine. It is verticals axis wind turbine, small size, installed on the rooftops of the building. In fact, few years earlier, I examined one of the PhD thesis from the Victoria University in Australia. So the researcher explored the possibility of using small size wind turbines on the rooftops of the building. Maybe if in the future this technology becomes commercially successful, in future we may see that these small size wind turbines are also installed on the rooftops of the buildings where there is good wind velocity, maybe along with the photovoltaic systems. Now let us talk about the another very important technology, photovoltaic systems. So how much electricity can be produced from these photovoltaic systems? How much is the potential? So the power which we can receive from the sun in terms of sunshine, how much power it can receive by the earth surface. So this power is of the order of 1.2 into 10 raised to power 8 gigawatt. So this power, if we can just tap for 1 hour, so how much energy it will produce? This energy, if we just tap for 1 hour, all power from the sun for 1 hour, so this power is sufficient for the whole world for 1 year. So you can see that there is huge potential from the sun, and you will see that how convenient it is to produce the electricity from the sun. Solar light just falls on the PV panel and produces the electricity. Whereas in case of other types of power plant like the coal, we have the coal from the coal mines. Coal will be crushed and then it will burn in the boiler, which will produce the steam. Steam will rotate the steam turbine, and then electricity will be generated. Here, simply we have the PV panel placed in the sun, and it produces the electricity. So how convenient, so many advantages we have from the PV systems, that it is highly environment friendly, highly reliable, having no moving parts, complete silent operation, very low operation and maintenance cost, and it can be very quickly installed. The one of the issue what we have with the renewable solar is that power produced is intermittent. During night, no electricity produced. During the day, power produced will vary if moving clouds comes. Other than that, like there are great advantages of the photovoltaic systems. Now you can see that what are the different types of PV systems. PV system can be connected to the grid. It can be small size or it can be large size power plant. So different options could be small size, even you can say street lights, it could be pole mounted, or it can be placed on the rooftops of the building, or even it can be integral part of the buildings. When we are talking about the large size PV plants, obviously it has to be installed on the ground. And as you'll know that the electricity produced from the photovoltaic system is DC. And if it is installed on the rooftops of the building, then most of our load is AC. So power has to be conditions, change DC to the AC before being used. And then of course we have the grid. So grid can act as the backup. And we can draw the power from the grid. We can supply power from the power to the grid as well. There can be a net metering scheme as well. When we are talking about the photovoltaic system, we can have like the standalone system in the remote areas. In the remote areas, we have to design suitable backup system, because in the grid connect system, the grid acts as the backup. So here backup will be in terms of storage system, battery storage system. Diesel generator can be optional. Then there can be another great application for photovoltaic systems in irrigation sector for like our country. So here we have the photovoltaic systems and DC motor being used for the water pumping application. We are not adding here storage system to have its low cost, and also that whenever there is sunshine, DC motor will run and it will produce, water. So this is another great application for the PV system. Now, how much is the installed capacity worldwide from the PV? So you can see by end of 2023, the installed capacity from the photovoltaic system is already more than 1600 gigawatt. If you compare with respect of wind you see started around 1980s, but this solar mainly you can see started say around 2007 in, or even say 2010. So in the last 15 years, you can see, or even the last 5 or 7, how fast or exponentially the installed capacity has been growing. As you see, the great advantages from the photovoltaic systems. Previously, there used to be one of the issue with the PV system, that the cost of PV system was very high because of the cost of PV panels. Now, cost issue is gone. PV system is now no more costly. I will show these how much cost we have now in the next slides. And then there are all great points. As I mentioned, only issue that it is intermittent, but with this with the integration of other renewable energy technologies, storage systems, so this issue we can overcome. So now we can see how fast this PV system is growing. And then you can see the countries which are leader in the power generation from the PV, China, US, our country is really doing great, Japan, etc. So this like now, if we see how much is the growth in the photovoltaic system, in the wind, we show that installed capacity worldwide will increase 10% as compared to the cumulative capacity of the all previous years. Here growth will be around 25 to 30%. So it means in 3 or 4 years, the installed capacity worldwide will just become 2 times, double. Now, when we are talking about the photovoltaic systems, you can see that photovoltaic system could be very small individual houses, or it could be little bit bigger size of solar systems in the university building, for example, or it could be like a very large size power plant. Talking about in our country, we have the two very big size photovoltaic power plants, more than 2000 megawatt capacity. So you'll see that this size of big power plant are spread over the large area, more than 50 square kilometer. And of course, significant cost as well. The another great point I want to mention, our company, National Thermal Power Corporation, which has business mainly in the coal and gas-based power plant, but now they want to diversify their portfolio in the renewables. So NTPC plans to construct 32 gigawatt of renewables by 2030. And then, of course, you can see this large size power plant in China, UAE, USA. So basically, the PV will grow very fast in coming years. Previously, I worked at University of Queensland. We used to have 5 megawatt photovoltaic system at the rooftops of the buildings in the university in several campuses. So through this website, you can find several interesting information. What are the different types of PV panels, storage system is there or not. You can find a lot of interesting information through this website. Now, when we are integrating photovoltaic systems, what are some of the integration issues? Integration issues will depend upon whether this PV system is small size or big size power plant. When we are talking about these small size integrations, then we will be exploring the issues like the effect of moving clouds. But when we are talking about the large size power plant, I'll give you an example of 2000 megawatt solar power plant. So the large size power plant, we will be studying the issues like the stability of the power system. I supervised one PhD student, and he worked on the power system stability with the large scale integration. Generally, question will come when we have this large size power plant connected to the grid, whether we should have storage system or not. If there is storage system, which way it can be beneficial. So for this University of Queensland example, for the utility, we'll see that there is one challenge, what we call that what we call is the demand profile. So managing the peak demand is a challenging task for the utility. But if the PV system has the storage capacity, it can help the utility in managing their peak demand. So during peak, so storage power can be supplied to manage the peak demand. This is another great point I want to mention for the University of Queensland, Australia. University of Queensland used to have their own 64 megawatt solar power plant. So any university having this like such a large size power plant, 64 megawatt power plant, so solar based. So this uses more than 2 lakhs of PV panels. This can generate power for feeding the electricity for the Queensland's homes, and it can used for some realistic research as well. Now, one of the question generally will come into mind that whether whatever we are talking about, the renewables like the solar or wind, are they really renewables or batteries? How much waste it will produce? So this is the reference, and you can see if you compare with respect to the waste being produced from the other systems, and it is like say year 2016 and say up to 2050. So waste coming from the municipal waste, the coal ash, etc. And then if you compare the waste from the, for example, PV module storage system, so you can see the comparatively the size as compared to this. So this waste coming out from the renewables, it is not as problematic as we can see from this like coal waste or from the municipal waste. So this is not a big issue with respect of renewables or battery storage system. How is the situation for our country? Our country installed capacity, and in 2023, mid 2023, it was around 417 gigawatt. How we are producing electricity, around 50% we have from the coal. You can say around 60% we have from the non-renewables. Around 40% we have from the renewables, includes wind, solar, bio, even the large hydro we are also include when we are talking 40%. Then how much is the potential in our country for the renewables? In fact, I examined one of the thesis. So you can see how much potential we have wind. Wind potential will be with respect of height, at what height we are exploring this potential. If we see that at 100 meters, so this could be, you can see that this is 300 so megawatt. So we have huge potential. How much is harnessed around? So this is like say 40 gigawatt. You can say 40 gigawatt we have from that what we have installed, and you can see the potential is 300 gigawatt. So we have huge potential. Then similarly, we have the huge potential from the solar and other renewable technologies. So I want to speak another one of the issues. In fact, I examined another PhD thesis from the Gandhigram in Tamil Nadu state. So one of the issue what we see is that land issue. As I gave you example of that the 2000 megawatt power plant, how much space it will need? It will need the area around 50 square kilometer. So land is one of the big issue. So how this land issue, can be tried to, taken care. So in this thesis, so this point was very nicely, explained that previously we used to have the wind turbine of the small size. So whichever are the existing small size wind turbine, they might have served almost their useful life. So they can be replaced by the large size wind turbines, and the space available between these wind farms, we can also have the photovoltaic systems. Not only that, even in the space we can have also the irrigation as well. So that way we need to have the proper multi-activities utilization of this space. Otherwise, land is one of the big issue. Then talking about the cost what we have from the renewables, wind and solar. If we see the cost from the wind, so around 15, we used to have the cost from the wind around 6 rupees per unit of the electricity. So this cost has come down now of the order of around 3 rupees per unit of electricity. What about the cost of the PV? So previously it used to be 6.5 rupees, but now this cost has come down really very less, around 2 rupees. In future, we may see that the cost can little bit go further down. So now there is no more a cost issue, and this is the sources coming from our country, Ministry of Non-Renewable Energy Sources. So our plan for our country, has great plan to boost the renewable energy by 500 gigawatt by 2030. And we also plan to have net zero by 2070. This let us see that how much we can achieve, but at least we have great plan. And we expect to reach closer to that. And then we expect to double our onshore wind, solar capacity, and achieve milestone of 50% non-fossil fuels. Obviously, we expect to achieve. So we have the great plans. Talking a little bit about the what we call as the hybrid power systems, microgrid, remote areas. So how we generate electricity in the past, mainly through diesel generator. Power produce is really very costly. Is it fine? I can take maybe 10-15 minutes more and then keep maybe an additional 10 minutes for the question answer.
Yes, sir. Yes, sir.
Okay, thank you. I really appreciate it. Because I don't want to just skip something which is really very interesting. So when we are talking about this, isolated power system, previously used to have the generator electricity in the remote area mainly through the diesel generator. So this diesel generator has several issues, very high cost of the fuel, transportation cost, operation and maintenance cost. Then how many hours this electricity will be supplied in the remote areas? Just like 2 or 4 hours, and just for basic purpose, 2 bulbs, 1 fan, something like that. But we also expect that the community also improve their living standard. They need more electricity. So hybrid power system could be a great solution. That diesel generator plant operated along with renewable energy plants, whatever resources available in terms of wind, sunshine, bio, micro hydro, so many. So this hybrid power system can supply power for more number of hours, and the community can get electricity, for they can use more equipments, television, and then they can use several other electrical appliances to improve their living standard. The cost of electricity can be significantly reduced as well by integration of renewables. So this microgrid isolated hybrid power system is really a great technology in the remote areas to reduce the cost. Even there are remote places we cannot have the grid supply. It could be because of several reasons, remoteness of the site, and so many other issues, cost aspect. So this isolated hybrid power system could be a great solution. I worked previously in the Fiji Island, a very small island country population, very small population, less than 1 billion. Of course, the power requirement is also not significant. I recall it will be around very small, around 400 megawatt. But the share of the diesel is significant. It could be say 30-40%. So more than 100 megawatt or 150 megawatt out of 400 being generated through diesel. So electricity produced from the diesel very costly because of the cost of fuel, transportation cost, etc. So integration of renewable can be a great solution. So then they had, small wind farm. Then of course, solar is coming up, several other renewable technology. So the cost can be reduced. So this hybrid technology can be a great solution. So here, my apology, you may not able to see very properly. So this is a paper published in 2015, talking about the comparison of the different renewable energy technology, wind onshore, offshore, solar, then several other technologies like the fuel cell, batteries, hydrogen storage system. What are the present status? I explained for some of the technologies. What are the research challenges and opportunities? What is the trend? We already reached 2025. So basically, you can see that successful renewables technology, currently we have wind onshore, offshore, PV, and then we are now started talking about the fuel cell, battery storage, hydrogen. In future, we can see that there are several other technologies which can be commercially successful as well. So little bit talking about the smart grid. The smart grid has three components. What we talk about the infrastructure in terms of generation, transmission, distribution, renewable energy integrations, microgrid, grid to vehicle, vehicle to the grid. We are talking about the electric vehicles as well. Then information systems, how we collect the information through smart meters, sensors, pressure measurement units. Then the communication system, role of communication system is really very important. So it could be wired or wireless communication system. How this smart grid will be managed, what will be the management objectives in terms of loss minimization, cost minimization, emission reductions, how this will be managed through these various tools and techniques, conventional programming, intelligent programming, machine learning, and so on. Then the role of protection system becomes extremely important in the smart grid. So maintaining of the privacy and security of the data is like one of the key aspects for the smart grid. So here in this smart grid is not the replacement of the existing grid, but to complement it with the features like we need to have both electricity generation from the centralized and distributed generation, integration of more and more renewables, electric vehicles are likely to come. The role of power storage systems becomes extremely important. Phasor measurement units are needed to maintain the health of the transmission system. Role of smart metering becomes extremely important for revenue collections, the management of the grid activities, avoid of the issues like the thefts. Customer can optimize their energy bills. And then of course, use of IT, information technology to optimize capital assets and reduce operational and maintenance costs. So from conventional to the smart grid, in smart grid, we need the electricity generation from centralized as well as the renewable distributed generation, electric vehicles are likely to come in smart grid, power flow becomes bidirectional. So there is two-way communications. Customer can communicate to the utilities. Utility can communicate to the customers through these smart meters. The smart grid has the property of the self-monitoring and self-healing. At the end, what customer gets, whether it is conventional grid or smart grid, the customer is interested that the customer have some choice. There is no more monopoly. Customer can get quality of electricity supply at affordable prices, and there is no more a monopoly. So this is just like says this an example of this smart grid. We need to have the different types of power generation, conventional, renewables, battery storage system, electric vehicles. So this is what it will form. So in smart grid, both how energy flows, how the communication is there. So the role of communication is extremely important. So I'm just at the end of the presentation. As mentioned by Professor Rajesh, I have examined many PhD students in several countries and still continuing. They have contributed significantly in publication of books, journal publications, conferences. So some of the books you can see: Protection Area, Smart Grid, Distributed Generation, Renewable Energy Technology. Even one of my PhD student worked in Australia, how we can improve the efficiency, reduce the emission from the coal-based power plant. We did the research on hybrid power system, how to control the frequency and reactive power. This is another book you can see talking about the power electronic drives and advanced applications. So I'm at the end of presentation. I would like to thank you all for listening, and I'm happy to take some questions. I'm happy to see that there are more than 200 participants. I deliver these lectures many times, but I have never seen like this such a big number, 200. Generally, this number will be around 50, not more than that. But I'm delighted to see that there are more than 200 participants, so which is really great. So please feel free to ask some questions.
You can unmute yourself if you want to ask any question.
Yeah, please, I expect few questions. Feel free to ask any general questions or any question you have. I know that there are participants from the different disciplines and different cohort, faculty members, PhD students, etc. So please, I expect some questions. Don't hesitate, please. You can welcome to ask any question you may have.
Dear participants, if there is any questions, please raise your hand.
So don't hesitate, please. Anyone want to ask any questions, you are more than welcome.
If there is any question, please raise your hand.
Even my contact details are here. So if anyone is willing to contact me later, so I'm more than happy to be contacted.
Okay, sir, as no one is asking, but let me ask a simple question.
Sure, please. Welcome.
You have talked about offshore and onshore wind plants.
Yes.
So apart from the constructional challenges, is there any challenge faced from electrical point of view?
Yeah, like electrical point of view, certainly there will be challenges, you see, for example, offshore, the maintenance is really one of the big challenge. The regular maintenance required in the gearbox generators. So you see that how this maintenance will be done, regular oiling. So you'll see that maintenance is one of the big challenge. Then electrical perspective, what we are seeing, the size of the converters, that is of course development challenge. The converter size ratings. So as renewables plants capacity growing, so we need to develop the converters of the high ratings. So there are so many challenges from electrical point of view, as the renewables are, highly unstable. The generation is unstable. Load is unpredictable. So it becomes like the big challenge for the power system. So there are so many challenges, perspective from the stability and maintenance. So there are several issues.
Okay, sir. Thank you, sir. Any more question, participants? You can unmute yourself and ask. Yes, Mr. Singh. Pinkesh Singh, please ask. Okay, sir. So I think there is no question from other participants.